Hi, this is Greg Monty, and this is the CERT Education Series, Heat Transfer Enrichment 2. It's all about the heat equation and weather impacts. We're going to develop a heat equation during this module. If you have a material and you wish to know how much heat will be needed to change that material's temperature, what factors do you need to know to calculate the heat needed? Let's take a closer look. Let's talk about the mass of material first. Will different masses of water require different amounts of heat energy to change their temperature the same amount? Well, let's look at an example. Let's take two beakers, one with 10 grams of water, one with 100 grams, and you want to raise them both the same amount of degrees Celsius, from 25 degrees Celsius to 35 degrees Celsius. Will different masses of water require different amounts of energy to change their temperature the same amount? I think everybody understands yes. Heat depends on the mass of material. Now let's talk about change of temperature. Given equivalent masses, will different temperature changes require different heat energy to be applied? Let's take another look at another example. Assume we have two beakers to start with, both with the same amount of water, 10 grams of water in each. And on the left-hand side, we want to raise the temperature just 10 degrees, but on the right-hand side, we want to raise the temperature of the 10 grams of water by 30 degrees, from 25 degrees Celsius to 55 Celsius. Will the same masses of water require more energy to raise the temperature different amounts? I think you all understood that heat depends on change of temperature. So now we know that it depends on mass and it depends on the amount of temperature change. Now let's think about the type of material. Will changes in temperature require different amounts of heat energy for different materials? Again, let's look at an example. 10 grams of water on the left in a beaker and 10 grams of aluminum foil on the right. And we want to raise them both by 10 degrees Celsius. Will it take different amounts of heat energy to do this? I think if you think about how you heat water on a stove, you know that the pot that's made out of metal heats up very rapidly, but it takes a while for the water inside to boil. So the reason for that is that those are different materials, and it indeed takes different amounts of heat energy to heat different types of materials. And every material has a defined characteristic called specific heat, which is the calories per gram degree Celsius that defines that material. So water and aluminum have different specific heats. So heat depends on the specific heat of the material and the type of material. So now we know that heat, which is measured in either calories or joules, as we learned in the heat transfer module, is dependent on material mass, the change in temperature, and the type of material defined by its specific heat. So heat equals material mass times change of temperature times specific heat. Let's think of an example. Let's calculate the heat that was transferred during the heat transfer experiment that we did within the heat transfer module. We had a hot cup of water, A, and that heat was transferred by the aluminum bar over to the cold cup of water in B. We had about 2 ounces of water in the B cup. That's about 57 grams. it went through about a 3 degrees Celsius change in temperature during the 5-6 minutes of the experiment. And specific heat of water is 1 calorie per gram degree Celsius. This is a constant for water. Therefore, if heat is defined by that equation at the top of this slide, you know that the heat transferred is 57 grams times the 3 degrees Celsius temperature change times 1 calorie per gram degree Celsius. And as you can see on that equation, the grams and the degrees Celsius cancel from the numerator and denominator, and you're left with 171 calories. So during that experiment that we did in experiment 1 in the heat transfer module, 171 calories approximately were transferred from the hot cup to the cold cup. Now let's talk about how the heat equation and heat transfer affect storms and hurricanes. What happens to a hurricane strength when it crosses warm water? It picks up heat energy from the water. This happens because there's a temperature difference. Remember, heat transfers from warm to cold, so warmer water moves up into the atmosphere into the colder, higher altitude hurricane. What happens to hurricane strength when it goes over land? It loses energy from the cooler, drier air below and from friction that the air has with land. Let's look specifically at Hurricane Matthew in 2016. There's a map on the right-hand side showing Hurricane Matthew and its movement from beginning to end. It started at 11 a.m. on the 28th of September as a tropical storm. And the question we have here is, what happened to the strength of Matthew when it was in the Caribbean? Well, by the time it moved over to September 30th, just 2 days later, it had become a Category 5 storm. So it had gained strength over the very warm waters in the Caribbean. What happened as Matthew moved north to Florida? By the time it was October 6th, it was a Category 4 storm moving towards Florida, and then became a Category 3 storm on October 7th. So as it moved northward, it decreased its strength because the waters got cooler and cooler, and it was picking up less heat energy, diminishing the strength of the storm. And then what happened to the strength when it hit land in South Carolina? Well, you can see at 8 a.m. on October 8th, it became a Category 1 storm over land in South Carolina. And as we said, we knew that it lost strength down to a Category 1. And that was because it picked up even cooler air temperatures from being over land, and it was meeting resistance of the wind blowing across trees and obstructions that are on the land. And lastly, it moved out to sea. Now let's lastly talk about climate change impact and storms, keeping the heat equation in our minds. If the climate change makes the oceans warmer, the temperatures will rise in the ocean. The warmer water will have more heat energy. Remember your heat equation. If the temperature goes up in whatever material you're thinking about, then that means it has more heat energy. And with more heat energy, what will happen if there's a larger temperature difference between warmer oceans and cooler air? Stronger storms are going to be seen. And this is what people are worried about with climate change today. Thanks for participating in the CERT Education Series, Heat Transfer Enrichment 2, all about the heat equation and weather impacts. Thank you.